For the AC network shown, calculate ZEQ, I1, I2, and I3. For the AC network shown, calculate ZEQ, I1, I2, and I3. Hello and welcome to my channel once again. So today we are going to solve this question. For the AC circuit shown, calculate ZEQ, I1, I2, and I3. So ZEQ is the equivalent impedance or the total impedance, okay, and then I1, I2, and then I3. So I1 is the current that flows through Z1, impedance Z1, and I2 is the current that flows through impedance Z2, and I3 is what the current that flows through impedance Z3. I hope you understand. Then we have our supply voltage, which is E, and that is equal to what, 100 angle 0 degrees volts. Okay, so we are going to solve for the equivalent impedance, that is ZEQ, solve for I1, I2, and then I3. Please make sure you subscribe to the channel. Okay, make sure you subscribe to the channel. So the solution. So first let's put our data down. Okay, so we have the supply voltage E to be what, 100 angle 0 degrees, and this is in what, volts. Then we have the impedance Z1, which is 300 plus J 400 ohms. Then we have the impedance Z2, which is 500 plus J 1200 ohms. Then we have impedance Z3, which is 800 minus J 600 ohms. Okay, supply voltage E is what, 100 angle 0 degrees. Z1 is equal to 300 plus J 400 ohms. Z2 is equal to what, 500 plus J 1200 ohms, and then Z3 is equal to 800 minus J 600 ohms. Alright, so let's go back to the diagram. When we look at Z1, it's having J 600 ohms and then negative J 200 ohms. So J 600 ohms is the inductive reactance, and then negative J 200 ohms is the capacitive reactance. Okay, so we subtract the capacitive reactance from the inductive reactance, that is negative 200 from 600, which will be 400. Okay, so that is the reason why on our data the impedance Z1 is what, 300 plus J 400 ohms. I hope you understand. Alright, so let's continue. So the supply voltage E, which has the value 100 angle 0 degrees, is in the polar form. Okay, 100 angle 0 degrees is in the polar form, and Z1, which is 300 plus J 400, Z2, which is 500 plus J 1200, and then Z3, which is 800 minus J 600, is also in the rectangular form. Okay, so we are going to convert the polar to rectangular, and then convert the rectangular to polar. Okay, because as we do the calculation, we'll be switching from polar to rectangular, and then from rectangular to polar. Okay, all right, so let's convert 100 angle 0 degrees into rectangular, and that is going to give us what, 100 plus J 0 volts. And then let's convert Z1, which is 300 plus J 400 ohms, into polar, and that is also going to give us what, 500 angle 53.13 degrees. And when we convert Z2, which is 500 plus J 1200, into polar, we are going to get what, 1300 angle 57.38 degrees. And then when we convert Z3, which is 800 minus J 600 ohms, into polar, we are going to get what, 1000 angle negative 36.86 degrees, and the unit is in ohms. Okay, I hope you understand. We converted from polar to rectangular and then rectangular to polar, because as we do the calculation, we'll be switching. Okay, we'll be switching. Okay, all right, so let's move on. So how do we convert from rectangular to polar? and then from polar to rectangular form. I'm going to show you, okay, step by step. All right, so let's take Z1. That is 300 plus J400. This is in rectangular form, okay. This is in the rectangular or the Cartesian form, okay, and we are going to convert this into polar, okay. All right, so to convert into polar, we have to find the magnitude, and then we find the angle. We find the magnitude or the real side, and then we find the angle, okay. So to find the magnitude, we use the formula, the square root of r square plus x square. R is the resistance, and then x is the reactance, okay. So we have the square root of 300 square plus 400 square. So the resistance is 300, and then the reactance is what? 400. So the square root of 300 square plus 400 square. I hope you understand. We use the formula, the square root of r square plus x square. R is the resistance and x is the reactance. So we have 300 to be the resistance and then 400 to be the reactance. So we have the square root of r square plus x square, and this is equal to what? The square root of 300 square plus 400 square. And this is going to give us what? 500 for the magnitude or the real. So let's move on to find the angle, which is the theta, okay, in degrees. And we use the formula tan inverse of x over r. X is what? The reactance, and then r is the resistance, okay. X is the reactance and r is the resistance. So this is equal to what? The tan inverse of 400 over 300, and that is going to be 53.13 degrees. 53.13 degrees. So the magnitude or the real is what? 500, and then the angle theta is what? 53.13 degrees. So to convert into the form r angle theta degrees, z is going to be what? 500 angle 53.13 degrees, okay. So that is what we have here, z1, which is 300 plus j400 ohms. That is in the rectangular. To convert into polar, we got what? 500 angle 53.13 degrees. I hope you understand. Okay, so let's now convert from the polar to rectangular, okay. Let's now convert from polar to rectangular. So we take z equals 500 angle 53.13 degrees. Z equals 500 angle 53.13 degrees. This is in the polar form. So we are going to convert it into rectangular, okay, into the form a plus jb. This is rectangular. A plus jb. This is the rectangular form. So we are going to change from the polar to the rectangular, okay. So a is the real, and then b is the imaginary, okay. All right, so let's first find the real, a, and that is equal to what? Cos theta times r. So we have cos 53.13, which is theta, that is the angle, 53.13 times 500, okay, the real 500, and that is going to give us what? 300. Cos 53.13 times 500 is going to be what? 300. I hope you understand. That is for the real part, a. Now let's find the imaginary, which is what? b, and that is also going to be sine theta times r. So we have sine 53.13 times r, which is what? 500, and that is also going to give us 399.9, which is approximately 400. I hope you understand. So to convert to the form a plus jb, that is the rectangular, a plus jb, that is the rectangular, you are going to get z equals 300 plus j 400, okay, 300 plus j 400. So you can see from the data that z1 is equal to what? 300 plus j 400, which is in the rectangular form, okay. And then to convert it to polar, we got what? 500 angle 53.13 degrees. So that is what I've illustrated here, how to convert from polar to rectangular, and then from rectangular to polar. I hope you understand. Okay, so now that you understand how to convert from polar to rectangular, and how to convert from rectangular to polar. Let's now solve for the equivalent impedance or the total impedance. But first, let's find the impedance in parallel, okay? That is ZP. And we use the formula product over sum, that is Z2 multiplying Z3 over Z2 plus Z3. So we have 1300 angle 67.38 degrees, which is Z2 multiplying 1000 angle negative 36.86 degrees, which is Z3, over 500 plus J 1200, which is Z2, plus 800 minus J 600, which is Z3. I said earlier that we converted from the polar to rectangular and then rectangular to polar, because as we do the calculations we are going to be switching. Okay, so here you can see that Z2 here is in polar form and then Z2 here is in the rectangular form. Okay, the reason is that we can only multiply and then divide polar. Okay, we can only multiply and divide polar. We cannot add, we cannot subtract polar. Okay, all right, I want you to understand this. Okay, so let's continue. So let's multiply 1300 angle 67.38 degrees by 1000 angle negative 36.86 degrees. So what we are going to do is we multiply the real and then we add the angles. So this is going to give us 1.3 million angle 30.52 degrees. 1.3 million angle 30.52 degrees over, now we add 500 plus J 1200 plus 800 minus J 600. That is also going to give us what? 1300 plus J 600. I hope you understand. Okay, so before we can divide 1.3 million angle 30.52 degrees by 1300 plus J 600, we have to first convert this 1300 plus J 600 into polar before we can divide, because the numerator is in polar form. Okay, all right, and that is going to give us what? 1.3 million angle 30.52 degrees over 1431.73 angle 24.77 degrees. I hope you understand. We have to convert this 1300 plus J 600 from rectangular to polar before we can divide. And that is what we have done here. Okay, we have 1.3 million angle 30.52 degrees over 1431.78 angle 24.77 degrees. So when we divide 1.3 million angle 30.52 degrees by 1431.76 angle 24.77 degrees, we are going to get what? 907.96 angle 5.75 degrees, and it's in what? Ohms. So when you convert to rectangular, we are going to get 903.51 plus J 90.96 ohms. Okay, so the parallel impedance or the impedance in parallel is equal to what? 903.51 plus J 90.96 or 907.96 angle 5.75 degree ohms. I hope you understand. So now that we have calculated for the impedance in parallel, let's move on to solve for the total impedance, that is ZEQ, by adding the impedance in parallel to the impedance Z1. Okay, so ZEQ, which is the total impedance or the equivalent impedance, is equal to ZP plus Z1. So ZP is what? 903.51 plus J 90.96 plus Z1, which is what? 300 plus J 400. Okay, and that is going to be 903.51 plus 300 plus J 90.96 plus J 400, and this is going to be 1203.51 plus J 490.96. 1203.51 plus J 490.96. And to convert this into polar, we are going to get what? 1299.7 angle 22.19 degrees, and it's in what? Ohms. So the equivalent impedance or the total impedance ZEQ is equal to 1203.51 plus J 490.96 or 1299.7 angle 22.19 degrees ohms. I hope you understand. So let's now move on to calculate for I1, I2, and then I3. But before that, let's calculate for the total current. Okay, so the total current IT is equal to E over ZEQ. E is the supply voltage, ZEQ is the total impedance or the equivalent impedance. Okay, so we have 100 angle 0 degrees, which is the supply voltage, over 1299.7 angle 22.19 degrees, which is the total impedance. Okay, so when you divide, you are going to get what? 0.076 angle negative 22.19 degrees, and it's in what? Amps. Okay, current is in what? Amps. So the total current IT is equal to 0.076 angle negative 22.19 degrees amps. Okay, so on the diagram, our total current will be at this point. Okay, so we can see that the total current flows through Z1. The total current flows through Z1 directly. So it means the total current is the same as what? I1. Okay, because I1 also flows through Z1. So IT, which is the total current, will be the same as I1. Okay, all right. So we can say that IT is equal to I1, which is equal to what? 0.076 angle negative 22.19 degrees amps. Okay, IT is equal to what? I1, which is equal to 0.076 angle negative 22.19 degrees amps. I hope you understand. All right, so let's now move on to solve for I2 and then I3. So before we solve for I2 and then I3, let's first find the voltage across Z1. Okay, that is VZ1, and that is equal to IT or I1 times Z1, and this is equal to 0.076 angle negative 22.19 degrees multiplying 500 angle 53.13 degrees, which is equal to 38 angle 30.94 degrees, and it's in volts. Okay, 38 angle 30.94 degrees volts, which in rectangular form will be 32.59 plus J 19.53 volts. So VZ1, that is the voltage across Z1, is equal to 38 angle 30.94 degrees or 32.59 plus J 19.53 volts. I hope you understand now. Okay, so let's move on. So let's now find the voltage across the parallel network. Okay, that is the voltage across Z2 and Z3. I hope you're following the calculation. First, we find the voltage across Z1, and that is 38 angle 30.94 degrees or 32.59 plus J 19.53 volts. Now let's calculate for the voltage across the parallel network, that is the voltage across Z2 and then Z3. Okay, so VZP, that is the voltage across the parallel network, is equal to E minus VZ1, that is the supply voltage minus the voltage across Z1. Okay, so we have 100 plus J0, that is the supply voltage E, minus 32.59 plus J 19.53, and that is going to be 64.41 plus J 19.53. And when you convert it into polar, you are going to get what? 67.30 angle 16.86 degrees volts. Okay, so the voltage across the parallel network, that is VZP, is equal to 64.41 plus J 19.53, or 67.30 angle 16.86 degrees volts. I hope you understand. So now that we have the voltage across Z1 and then the voltage across the parallel network, let's now move on to solve for I2 and then I3. So I2 is equal to VZP, that is the voltage across the parallel network, over Z2, and this is equal to 67.30 angle 16.86 degrees over 1300 angle 24.77 degrees, and this is going to be 0.051 angle 50.52 degrees amps. Okay, so I2 is equal to what? 0.051 angle 50.52 degrees amps. So I3 is equal to what? VZP over Z3, that is the voltage across the parallel network, which is VZP over Z3, and this is also going to be 67.30 angle 16.86 degrees over 1000 angle negative 36.86, and it's going to be 0.067 angle negative 53.72 degrees amps. So thank you so much for watching the video, and please, if you have not subscribed, make sure you subscribe to the channel, okay, for more videos. Thank you.